Hey everybody, I'm sorry that I can't be in class, but these are what we would have gone over. So first, before you watch this video, make sure that you have tried these practice questions so you have an answer for all of them before you check them with my work, just to make sure that you have an understanding of what is going to be covered. So if you have not yet tried them, please pause the video, try them first, and then you can check them with my work. Okay, the first question here asks us to find the axis of symmetry, and they give us this equation. The axis of symmetry formula we went over on this page of notes, so we can just write that down from the notes. So x equals a negative b over 2a. Then we just need to identify the a and b from the equation. So I can see that the a is the negative 1, remember that's the number with the x squared. B is negative 2, that's the number with the x. And then I can sub those into my formula. So then we have this x equals negative, and then I plug in the negative 2. And then in the denominator, we have 2 times the negative 1. Now, depending on which calculator you have, you can go ahead and simplify this by just putting it in your calculator, or we can simplify the top, simplify the bottom, and then divide. Either way, I will write out what you would get in the in-between step. 2 over negative 2, and then that will become x equals negative 1. Again, either way you did the answer, you would get that as your solution. So my answer to this question is option 2. Okay, question number 2. What are the coordinates of the turning point? Now this is up just a little bit on this page, tells you the directions to find the turning point of the parabola, whose equation is, and then we have this equation. So the directions, like I said, are up above. We need to find the axis of symmetry first. That'll give us an x value, and then we can sub that in to find out what the y value is. So again, just the same formula. Then we're going to fill in our a and b. We need to identify that underneath the quadratic. The a value is the number in front of x squared. That's a 1. And then the b value in front of the x is negative 4. So then those are what we would plug in to our axis of symmetry formula. So that becomes a negative 4 over 2 times 1, and again, just depends on which one you're going to do in the calculator, if you're going to simplify the numerator first, and then denominator, or just put it in as a fraction. Either way, you'll get the x value of 2. Now that we found the x, when we know what x is and we're looking to find a y, we just substitute the x in place of the x in the equation. So we sub in the 2 squared minus 4 times 2 plus 4, and that ends up giving us a y value of 0. So now I know my x value and my y value, which tells me that my solution is 2, 0, which is written as a point x, y. So answer 1 in this question. All right, down to number 3. Given the quadratic function graph to the right, draw in the axis of symmetry. So what is the axis of symmetry? And you can look back if you need to know, but it's the line that will then cut the parabola in half. If we folded it in half on this line, that would make it symmetrical on both sides. So that's what the axis of symmetry is. So it has to go right through the middle. Now if we look through here, I can see that my minimum point kind of is between these two values. So we're going to go halfway between. That's where the axis of symmetry would be. So with the straight edge there, you can draw that line going right down the middle of that parabola. Now the axis of symmetry, when we state it, it's a vertical line that cuts the quadratic in half. So you need to make sure you start with x equals, not just 3.5. 3.5 is from, if you count over, that's the value where that line is. But you have to have the x equals 3.5 because otherwise we don't know that it's a vertical line, and that's a common error that I see. So make sure that you write down x equals 3.5. Now from there I can find the turning point, because the turning point is that the axis of symmetry goes through the turning point, so it's down here. So the turning point would be the x value from the axis of symmetry, so 3.5, and then if we count, it goes down 4. So my point would be 3.4 comma negative 4. And because when we look at the graph, that's the lowest point on the graph, that makes it a minimum. So you always just look to see, is it a maximum or a minimum? Is it the highest or the lowest? And then to find the zeros, remember that the zeros are where it crosses the x-axis. That's another word for the roots. Zeros, we talked about that in the previous unit, but it's where it crosses the x-axis, the x-intercepts here. So those would be at the values 1 and 6. And you could write those out separately if you wanted x equals 1 and then x equals 6, or put it in the set notation like I did. Okay, on to the next day notes. Exploring key features of quadratic graphs. To find the x-intercepts of an equation or graph algebraically is what we did the previous unit. That's when we know y equals 0 and we just put it in the equation and solve for x. So remember, the finding the x-intercepts means that in order to be on the x-axis, I cannot move up or down at all. That's how I know the y value is 0. Graphically, they are called roots or zeros, and it is where they cross the x-axis. So given the quadratic graph shown, the graph is called a parabola, and that's also a review. So we're going to do the same thing that we did in the previous. We're going to draw in the axis of symmetry and state it. So again, remember that that axis of symmetry is what cuts it in half, and we have to write it as x equals because it's a vertical line, and then we can look at the graph to see that it's at an x value of 2, so x equals 2 is my axis of symmetry. From the axis of symmetry, we can go ahead and find the turning point because it is the axis of symmetry goes through the turning point, otherwise it wouldn't cut it in half. So my turning point is right 2, up 1, so that's 2, 1. And when I look here, it is a maximum because it is the highest point on the graph. Now, would it be a negative or a positive? Pause and think about that for a second. What do we think? Now, I just said it's negative because the parabola opens down or faces down and has a maximum point. I like to think about it as, if things are sad in your life or negative, you're going to be probably frowning, and if things are really happy and positive, you're going to be smiling. So kind of think of like a smiley face parabola and a frowny face parabola. What are the roots of this quadratic? Again, this is all review from what we just did in the previous. The roots are where it crosses the x-axis. Roots, zeros, x-intercepts all mean the same thing. So if I look here, I can see that it crosses the x-axis at a value of 1 and a value of 3. Now, this part's a little trickier. We have to think about what would the factors of this quadratic be. So we are having the roots, the answers here. So if we think back to like the previous unit, when we were given quadratics, we were trying to find the x-intercept or the roots or the zeros. So now we need to work backwards from the answer to go back and find out, well, what would that factor have been? So I just set up like a t-chart, and then at the bottom I'm going to put my answers. So my answers, the roots, are 1 and 3. But if we think about when we had the factors, we set the factor equal to 0, and then we got x by itself. So now I want to move this 1 over to make it equal to 0 again and have the number over with the x again. So as you can see here, I kind of worked backwards. I subtracted the 1 back over to be with the x. So the factor that I would have set equal to 0 is x minus 1. And then I'm going to do the same thing on the other side. So when we subtract the 3 back over, then that means x minus 3. So my factor would have been the x minus 3. So now the answer to my question here for part F is x minus 1 and x minus 3. What do we notice about the roots and the axis of symmetry? So if we look here, how does the axis of symmetry relate to the roots? So pause the video and think about that for a second. See if you can come up with a way that those roots relate to the axis of symmetry. So if you look there, the roots are equidistant from the axis of symmetry. What does that mean? The axis of symmetry is right in the middle of the roots. So that makes a little more sense to you. Okay, now for the rest of this page, I'm just going to give you hints on what you need to do, but you're going to try it on your own. So on this next part, given the quadratic function, and we have this function here. So this is more of like an algebraic route that you're going to be taking. Find the axis of symmetry. So when you do that, you're going to use the axis of symmetry formula. When you find the turning point, remember that that is just like what we did where we found the axis of symmetry first and then plug that value in place of x to find out what the y is, and then we write that as x comma y. The y-intercept, in order to be on the y-axis, that means I can't move left or right at all, because if I move left a little bit or right a little bit, I'm off the y-axis. So the x value would have to equal 0 for this. The x-intercepts, that one, to go on the x-axis, we can't move up or down at all. So that means that the y value has to be 0 in order to not move up or down at all. So that's what you would do for this one, make y equal to 0. When you do that, you're going to have 0 equals x squared plus 4x plus 3. So I'll write that down as your kind of hint. And then that's just like what you did in the previous unit. You're going to either need to factor or use the quadratic formula. I would suggest factoring for this example, and then that'll help you solve for the zeros. So that's your hint for D. And then when you sketch your graph, you're going to want to start by graphing the axis of symmetry, the turning point, the roots, and I would also graph the y-intercept so that you can know where those points all are. And then think about it. Is it a smiley face or a frowny face parabola? And go ahead and connect your points to sketch what the graph would look like. But it needs to have the correct axis of symmetry, turning point, and roots in order to have an accurate sketch. Okay, my hints for this next page are to make sure that you determine the minimum point. That's just another way of saying find the turning point. So you're going to want to make sure that you find the turning point. So remember that means find the axis of symmetry first. So you're going to find the axis of symmetry first, then substitute it into the equation to get your y value. So that's what you're going to do to find the y. Okay, so that'll be your x comma y, that's your minimum. And then when it asks you what would that be called, that's what is another word for the minimum point. So that's my hint for you for there. If a parabola has zeros at -2 and the axis of symmetry at 1. So I'm just going to kind of sketch that off on my graph here. If it's a 0 is at -2, so I'm going to go back 1, 2 places. So I'm going to draw smaller marks to show down, back 1, 2. And then the axis of symmetry is at an x value of 1. So I'm going to put points there. And this goes back to that whole idea of that the axis of symmetry is exactly in the middle. So think of how far away is the 0 here. Well, if we go 1, 2, 3, that would get me to the axis of symmetry. So then I would need to do the same thing going this direction to find out that my other root would be at an x value the same distance away as the first root was. So that tells me my x value would equal 4. And that's your answer for that one, because that would be the other 0. That would be where the other root was. So that's my hint. The reason I did this one is because question number 5 is kind of similar. You're going to try question number 5. Okay, and the last question, given the quadratic graphs below, you're going to find the axis of symmetry, turning points, identify if it's a max or a min, and the zeros. That's all review of what we've been doing. And then you're going to write a possible equation in factored form. That might be a little new. So if we think about quadratic equations like we were doing in the previous unit, we were always had ax squared plus bx plus c. So now what we're going to do is we're going to make that, in the previous unit, we took that and we changed it to look like the two factors, whatever they are. So that's what you're going to do here. You're going to find the two factors, kind of similar to what we did on that previous example. You're going to find those two factors, and then you're just going to set it equal to y. So that's what your answer will be for part D. It will be y equals, and then the two factors in parentheses. Okay, hopefully that helps. Have a great rest of your day. You can send me any emails if you have any questions.